हेलो फ्रेंड्स, वेलकम टू बिंदु डडवाल केमिस्ट्री लेसन्स। अपने पिछले लेक्चर में हमने बॉयल्स लॉ, चार्ल्स लॉ, एवोगैड्रोस लॉ, गे-लुसाक्स लॉ किया था। आज हम कंबाइंड गैस लॉ करेंगे और आइडियल गैस के लिए इक्वेशन पे अराइव करेंगे। तो जब हम बॉयल्स लॉ और चार्ल्स लॉ और एवोगैड्रोस लॉ को कंबाइन करते हैं तो हमारे पास एक इक्वेशन आती है विच इज ओबेड बाय एन आइडियल गैस। तो इस इक्वेशन को हम आइडियल गैस इक्वेशन कहते हैं और जो गैस है उसको आइडियल गैस कहते हैं। तो अ गैस विच ओबेज बॉयल्स लॉ, चार्ल्स लॉ एंड एवोगैड्रोस लॉ strictly is called ideal gas. Now such a gas is hypothetical because in everyday life the gases that we see, they obey these laws only at high temperature and low pressure, so it is hypothetical. The three gas laws can be combined together in a single equation which is known as ideal gas equation. According to Boyle's law, at constant temperature and number of moles, the volume of a gas is inversely proportional to its pressure. So V is proportional to 1 upon P. And according to Charles' law, at constant pressure and number of moles, the volume is directly proportional to the temperature. And according to Avogadro's law, at constant pressure and temperature, the volume of a given mass of a gas contains equal number of moles. Now, if we combine these three statements, on the left hand side is volume, and on combining the right hand side terms, we get V is proportional to NT upon P. V is proportional to NT upon P. If we remove the sign of proportionality, we have to introduce a constant R. So equation becomes V is equal to R NT upon P. On rearranging and taking P to this side, we get PV is equal to nRT, where R is the proportionality constant, and the equation so obtained is called the ideal gas equation. If we consider this equation further, then we see that PV upon T for 1 mole of a gas, N is 1. PV upon T is equal to R, which is a constant. So that means that PV upon T is constant, or P1 V1 upon T1 will be equal to P2 V2 upon T2. This is another way of stating the ideal gas equation. Because this gas equation holds all the four P, V, N and T variables together which determine the state of a gas, so this equation, ideal gas equation, is also called equation of state. We can arrive at this equation in another manner. For this, consider a known quantity of gas at pressure P1, temperature T1 and volume V1. To convert it to another state at pressure P2, volume V2 and temperature T2, we can follow these two steps. Step 1, we will change the pressure of the gas from P1 to P2 at constant temperature. So we want to convert a gas at P1 V1 T1 to P2 V2 T2. In step 1, we will keep the temperature constant T1 and we will change the pressure from P1 to P2. Then the volume will accordingly change, because according to Boyle's law, pressure is inversely proportional to volume. So we get P1 V1 is equal to P2, and let the new volume be Vx. So P1 V1 is equal to P2 Vx. Now finding the value of Vx, we take P2 to the other side, we get Vx is equal to P1 V1 upon P2. This is equation number 1. Let the temperature of gas be now changed to T2 at constant pressure. We'll keep the pressure P2 and we will change the temperature from T1 to T2. Again, the volume will change from Vx to V2. And according to Charles' law, Vx upon T1 will be equal to V2 upon T2. Now again, finding the value of Vx, we take the T1 to other side, we get Vx is equal to V2 T1 upon T2. Now in both the equation 1 and 2, we have on left hand side we have Vx. Left hand side is equal, so we can equalize right hand sides also. So we get P1 V1 upon P2 is equal to V2 T1 upon T2. Now taking T1 to this side, we get P1 V1 upon T1, and P2 to this side we get P2 V2 upon T2. So we arrive at the same equation, P1 V1 upon T1 is equal to P2 V2 upon T2, or PV upon T is constant, equal to R. So we arrive at the ideal gas equation. Now this gas constant, this constant of proportionality, which is known as gas constant, its value can be obtained from this equation. R is equal to PV upon NT. PV upon NT. Now R is called the gas constant, and it is same for all the gases, so it's also called universal gas constant. The value of R depends upon the units in which pressure, volume and temperature are measured. Consider the equation PV is equal to nRT. R is equal to PV upon NT. So R is equal to pressure into volume upon number of moles into temperature. But pressure is force upon area, and area is length square. So we get, and volume is length cube. So putting these value, we get force upon length square into length cube. This cancels out and one length term is left. So we get force into length upon moles into temperature. Now the units, but force into length is equal to work. So R will be work upon moles into temperature. So units of R can be units of work, joule per mole per Kelvin. Numerical values of R when we are taking different units for pressure and volume. So when pressure is expressed in atmosphere and volume in liters, then R is equal to P into V upon N into T. P is 1 atmosphere. Volume occupied by 1 mole of a gas at this pressure and temperature is 22.4 liters. So putting this value, 1 atmosphere into 22.4 liter upon 1 mole into 273 Kelvin. So on solving, we get the value of R equal to 0.0821 liter atmosphere per Kelvin per mole. Now when pressure is expressed in atmosphere and volume in milliliters, now milliliters is a smaller unit, so the value of occupied by 1 mole of a gas will be in milliliter 22,400 milliliter. Substituting this value, because we get 1 atmosphere into 22,400 milliliter upon 1 mole into 273 Kelvin, answer comes out to be 82.1 atmosphere milliliter per Kelvin per mole. Third condition, when pressure is expressed as pascals. So instead of 1 atmosphere, we will write 10 raised to power 5 pascal for 1 bar. And volume in meter cube. Now volume occupied at 1 bar is 22.7 into 10 raised to power minus 3 meter cube. So putting these values, we get R is equal to 8.314 Newton meter mole inverse Kelvin inverse. But Newton meter is also called joule, so we can also say 8.314 joule per mole per Kelvin. Fourth condition, when pressure is expressed in bar and volume in decimeter cube, then R will be expressed in bar decimeter cube per mole per Kelvin. Now 1 mole of a gas at STP, that is 1 bar pressure and 273.15 Kelvin, will occupy 22.7 decimeter cube. So substituting this value, the value of R comes out to be 0.0831 bar decimeter cube mole inverse Kelvin inverse. So be careful, children, even though R may be expressed in different units, but we have to take that value of R for our numerical problems for which the units are same as those of pressure and volume. So if in any numerical your pressure is in atmosphere and volume is in liter, then you will use this value of R, 0.0821 liter atmosphere Kelvin inverse mole inverse. If pressure is in atmosphere and volume is in milliliters, then the value that will be substituted for R is 82.1 milliliter atmosphere Kelvin inverse mole inverse. So just learn this table. For pressure in bar and liter, you have this 0.08314. Pressure in bar and volume in decimeter cube, 0.08314, same. Pressure in pascals or Newton per meter square and volume in meter cube, then you take 8.314 Newton meter Kelvin inverse mole inverse or Joule Kelvin inverse mole inverse, 8.314. So let us now take a practice problem. A sample of nitrogen occupies a volume of 1 liter at a pressure of 0.5 bar at 40 degrees centigrade. We have V1, we have P1, we have T1. Calculate the pressure. We have to find out P2. If gas is compressed to 0.225 ml, that is V2, and minus 6 degrees centigrade, this is T2. So P1 0.5 bar, P2 we have to find, V1 1 liter, V2 0.225 milliliter. We will convert milliliter into liter, so this comes out to be 0.225 into 10 raised to the minus 3 liter. T1 is, it was 40 degrees centigrade in Kelvin, we add 273, so it is 313 Kelvin. For T2 it is minus 6, 273 minus 6, 267 Kelvin. Putting the values in the gas equation, P1 V1 upon T1 is equal to P2 V2 upon T2, we get P2 is equal to P1 V1 into T2 upon V2 and T1. Putting the values, we find out the answer. The P2 value will be 1895.6 bar. So very easy. Of the 6 terms, you substitute the values of 5 and you can find out the unknown one. This numerical is for you to practice. You have been given temperature at 25 degrees centigrade, pressure 760 millimeter of mercury pressure. A gas occupies 600 milliliter volume. What will be the pressure at a height where temperature is 10 degrees centigrade and volume of gas is 640 milliliter? So just write the answer in the comment box. Thank you. If you like the video, please do share and subscribe.